This last 18 months has seen a huge build-up in actually getting parts. So we've finished the design phase, where we've got like 20, 30 more components to get finished and completed. And then it's very much getting those parts in and getting them assembled and all put on the car to get ready for runway testing. As far as manufacturing parts go, so we've completed probably 90–95% of the parts we need are already here in this building. And it's just those last few to get put together. And a lot of those are to do with the other systems we haven't tested yet. So we've got things like the rocket system testing. So we're going to be doing that later on this year through the early part of next year. And then it's kind of getting the switch between the runway car and then moving that onto the desert car into South Africa. I mean, the challenges on Bloodhound I've been on it now for 8 years, and the original challenges were things like vehicle stability and the aerodynamics and the drag. And as we've gone forward in the project, that's why it's such a fantastic project to be involved with. They keep changing, they keep evolving. So now it's into production and manufacture, and then we'll be moving to testing. The breadth of engineering we have in this project, it isn't just a car project, it isn't just an aircraft project. We've got people from a background from aerospace, from automotive, from defence, from the rail industry. We've got people that have got HNCs and HNDs and apprenticeship background. We've got people that have got degrees and masters and PhDs. And it's a huge melting pot of all those skills you need. And kind of when I go to industry and I say, what is unique about Bloodhound? It's how we've managed to get all those people to work together and that's what's created the project that we have today. But here is the monocoque. This is a carbon fibre structure. So this is Andy's office. This is where Andy sits for the run. Massively strong. Really fortunately working with companies such as URT to be able to produce this for us. We have some other things a bit unusual you won't see on Formula 1 cars. So these are iced water tanks. So we have a car engine on the car, so the Jaguar AJ133. We can't have a radiator, so we reject all the heat into tanks of iced water that sit outside of Andy Green. So we use that for cooling the electronics and also for the car engine. Behind it is a ballistic panel. So what we see at the front here is where the front suspension is. So the wheels are turning 10,500 RPM. If a part of the wheel were to fail or a stone get flicked up, that's travelling faster than a bullet. So this is a ballistic armoured panel to protect Andy from any debris that came up. The inside of the cockpit is very much custom to Andy. This is a car built with one driver in mind, and he's been key in how that ergonomically works. The biggest thing he's worried about, people go, will it be really hot, will it be really cold, will he be air conditioned? Actually, he's only sat in it for about 5 minutes. A run 0 to 1,000 to 0 is less than 2 minutes in duration. The bit that he's most concerned about is the noise. Here we have the intake for an EJ200 jet engine. There's a shock wave from the front of the canopy that starts here. There's a normal shock across here. So we're in this area here, we're slowing air down by something like 400 or 500 miles an hour. And it's rushing right about his head. His head height is about 1.5 inches below the top of this canopy. So people go, what's the most, is it the G-force, is it the temperature? It's actually going to be the noise is going to be the issue. So where we are and what you see in the workshop at the moment on the car, we're doing a kind of a trial build of the entire car. So we're getting ready for going to Newquay for the runway testing. So actually taking the opportunity to actually build the car up in its most complete form that we've had it to date. Currently we've been working on individual systems, so this will be the first time over the next few weeks we have the whole car nose to tail put together. So what we've got here is one of the last components to get finished. So this is the fin of the car. So we are a car, but we have a very aircraft-like fin. Because we're running at 2,500 feet altitude, 1,000 miles an hour, no aircraft has ever actually managed that. So we are pushing the boundaries of what the structure can do. We've kept it very, very narrow to reduce the drag on the whole car. It's a riveted structure. This is an aluminium skin, aluminium ribs and stringers. What you can see down here is all the instrumentation. So we're always gathering information on the car. So we have strain gauges, pressure tappings, and accelerometers. So we're worried about things like flutter. We're worried about differential pressures across the car. And so this is essential to have all this buttoned up and ready to go. So what we have here is a service table. So although this car is 41 foot, 14 meters long, it has to be manufactured with a very high degree of accuracy. So we've got 2 surface tables that we put together front to back. What we see here is the rear structure. You've seen the monocoque where Andy sits. That's what bolts on the front here. As we move further back, we've got fuel tanks, avionic bay, more jet fuel tanks, close-out panels for the air brakes, and finally onto the rear suspension. So this is where the rocket sits in, but also where the suspension components are assembled. So it looks very conventional. If you saw this on a CAD screen, it looks like a normal race car, a normal sports car. When you see it in the flesh, these things are colossal. and the loads on them are tremendous. And probably this part of the car here is the most highly loaded, because not only do you have the suspension loads, you've got the rocket thrust loads coming through it, you also have on the back here, this is where the parachutes sit, and this is where the parachute strops are attached to. So as far as the most stuff going on, the most energy in this car, it's these components here are going to have the highest force in the whole vehicle. So what we have here is the upper structure of the car. So this is a titanium skin on an aluminium rib structure. Again, very traditional aerospace. If you look at it down the end of the car, it would look like the inside of an aircraft. The titanium, as we move further and further back, comes to an area of double curvature. Now, if we were doing this for a manufacturing for like an aircraft, you'd do a whole load of tooling, a load of development work to get these panels to fit. We don't have that luxury. This is a one-off vehicle, there's no prototype. So actually we've gone back, I won't say back in time, but this is all English wheeled. So we made a buck, had some very skilled craftsmen, artisans, that wheeled this for us in titanium. Now titanium isn't a very forgiving metal, and they weren't, after they'd done the first set of panels, they weren't very keen, we had a load more to do. But actually, the skills that it demonstrates that people can produce fantastic 3D shapes, and likewise on the fin, by hand and by skill, marking up with a marker pen, rolling it out, is outstanding. So the next couple of months what we're going to see is doing that, if you like, dry build of the car. So a nose to tail build of all the systems, getting everything in, getting it all starting to talk to each other, to basically debug it for us, to see what bits don't quite work how we expected. So after a couple of months we'll then start to strip it back down again, then build it up from scratch for doing runway testing in Newquay. And that's kind of the first time we'll see it run under its own power. We're going to find a huge amount more information out, and then it's then prepping that to go out to South Africa.